started recording. You will have to give me your consent.
Hello, everyone. We're going to be talking about asteroid diameter predictions. My name is Prati Patel, and my degree major is in computer science.
Hi, myself, Payal Nandi. My degree major is in aerospace.
So the data source as listed here, we're using the primary and the secondary data source. Our project goal for this project is to estimate the asteroid diameters. The diameter of the asteroids can be calculated based on the independent orbital elements. We are also using different prediction methods to calculate the diameter based on the available independent variables from the data set. And finally, we have evaluated the different algorithms using R2 score. Our target audience is aerospace organizations, weather and news channel organizations, independent research organization, and amateurs.
So here we have looking at the diameter of an asteroid to analyze the impact, as we have the independent variables like the orbital elements. Based on that, we are going to calculate the orbital diameters of asteroids. So yeah, this asteroid diameter will give us very information about like the orbit the asteroids are traveling and how fast it is traveling and how close it is to our Earth.
The hypothesis. We would like to achieve an accuracy of 100% for the prediction of asteroid diameters. This will help us in the future for situations awareness from preventing major destructions from happening. Our project plan is as followed, and moving to step 1.
Yeah, so in step 1, we have loaded our primary data. We uploaded the database in the local drive, and then these are the initial codes. We mounted it in the, and here we can see the reading of the data set. So which is like 27 columns and about 8,100 rows. So based on that, we perform the step 2.
In step 2, we're differentiating the data and checking for null values and insignificant values. So we have classified the columns according to our needs. So defining the columns, A equals to semi-major axis, which is the size, E equals to elasticity, which is the shape, I equals to inclination, which is the tilt, Q equals to the distance, H equals to absolute magnitude, the physical hazardous or PHA, then geometric albedo, which is the value. So over here, we're checking all the columns. Over here, we're trying to understand what type of data we're dealing with. Over here, we're analyzing the column percent of null values. And over here, we're doing a visual representation of the null values. And over here, we're deleting the rows of null values to make them numeric. Over here, we're also removing the columns with rows of null values. And as we go down further, we go to step 3.
Yeah, so here we are performing the analysis of the columns distribution. So if you look at the chart here, we can see the columns are distributed quite variant. Few have data and few we can see most of them are empty. And we will try to eliminate those columns and we can move ahead to step 4.
Step 4 is the visual representation of the data variance. Over here, we prepare the scatter plot for a better visualization. Given the row readings, we are actually preparing the data sets. And over here, we can see correlation matrix. As we see, the negative 0.6 are the less accurate ones, and to 1%, they're the more accurate ones. And as we see in the correlation matrix, we have a very variance of the data sets, and we see that they are distributed quite differently. Over here, we have many variations of scattered plots of the density. As we can see, there are many linear and non-linear scattered plots, and also we see lots of clusters, and we also see very dispersed data sets.
So moving ahead to the step 5, which is prediction. Here, first part, we have separated the data set into two, like test set and this training set. So it is like 80-20 ratio. Here we have a display of our X train And later we have normalized all the data set, so we can calculate the data based on an average value. And on the part two, we have done the regression using different methods like linear regression, elastic net, k nearest neighborhood, decision tree, etc., etc. So here in the linear regression, we have achieved a score of 0.659. Looking at the graph with the line fitting graph, we can see there are a lot of outliners, and also the overlapping is very less on the distribution plot. So moving ahead to the elastic net, we can see we have achieved the 0.625, and the graph displays a lot of outliers, and the distribution plot is also like 70% overlap. Moving ahead to the k nearest neighborhood, we have achieved the highest so far, which is 0.716. And looking at the graph, we can see a good percentage of overlapping between the stage value and the prediction, and very few outliers. And the decision tree, we have like 0.519, which is the lowest so far. And also the test value and prediction values are very different and scattered. In the test value, we can see it is like scattered.
In the random forest regression, we achieved a score of 0.754. And when we look at the test values, they are pretty straightforward. They go with the line. And in the distribution plot, they do overlap quite a bit. In the neutral network regression, we achieved a score of 0.687. And when we see in the test values, although they are scattered, they are pretty much dense with the line. And also in the distribution plot, it does not cover the full thing. In the XG boost regression, we got a score of 0.682. And when we look, there's lots of scattering, and it does not, in the distribution plot, it does not overlap it.
Yeah, so here we have the various columns and their importance. According to this chart, we can understand how important where each column data is. So we have the inclination, we have the major axis, and the mode.
In part two, we're comparing and scoring the best results. So as we can see in the bar graph, we have our forest as our highest score, and the rest of them are more than 50%, but they're not as high as the our forest. So our goal and end result. The goal of this project is to predict future paths of asteroid orbits. If the observation diameter goes beyond a certain diameter, its path comes closer to hitting the Earth, so we can prevent that from happening. The goal is to create a program with using existing data sets from a reliable source to help predict the future events of asteroids hitting the Earth. The end result is that we took data sets of 50,000 data. Our linear regression is 0.66. Elasticity net regression is 0.63. K nearest neighbor regression is 0.72. Decision tree is 0.54. Random forest regression is 0.76. Neutral network regression is 0.74. XG boost regression is 0.68. And as we see that the score for all of the regression is over 0.5, which is more than 50%. Our goal was to create a prediction program that would give accuracy of 100%, but unfortunately we were unable to present an accuracy result between 100%, so we can only do it between 0.6 and 0.8. If we had more time and much better technological knowledge, we would have been successful in presenting it closer to the 100% accuracy rate. So the programs we have used are Pandas, MPL Toolkit, sklearning, pre-programming, NumPy, OS, and obviously Google Colab. For the conclusion, April's going to be taking over.
Yeah, so the conclusion is we have achieved the accuracy of around 0.75 with our random forest algorithm. And we can improve it. We have a better data set in the future, and obviously we tweak our variables. So we're looking forward to that. And the future work, we will be working on the distance, like perihelion distance, and also try to achieve 100% accuracy with that.
For the future, we also want to make sure that the data is clear and concise to elaborate on when working with. We also want to try to create a data set specific to main topics. So in the future, the data is separated into clear and concise parts. And lastly, also our goal is to make sure that the information that is being put out for the asteroid hitting prediction comes with many alternative solutions to prevent those situations from ever occurring. Thank you so much for listening to our presentation. We hope you enjoyed it.
Thank you,
Thank you.
everyone. Thank you, everyone.